This is exam 2 review of business math 1324. It is additional review to your professor review. This is a complete review of chapter 5 Mathematics of Finance that covers simple interest or loan, that is less than a year investment, that is a short-term investment, compounded interest, it is a long-term investment or loan, more than a year investment, ordinary annuity and annuity due is a monthly payment, continuous investment or loan, and more. This is a good review tutorial for students in business math, finite math, financial mathematics, college algebra, high school algebra 1 and 2. I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. This chapter 5 and chapter 7 linear programming are also good for any person who is interested in investment and running a business. There are many real-life applications problem solving in how to make good investment decision and run a business. I always advise my students to take this class, this business math class 1324 and business calculus math 1325. These two courses are well designed and will help you succeed in your higher education, such as MBA, finance, economics, marketing, supply chain, etc., all the way to PhD. Beyond higher education, they will help you in how to make good investment decision and run a business. So the first 8 questions are about simple interest, which is an investment or loan, a short term, which is less than a year, and they cover future value and present value of simple interest and more. Number 1, simple interest. Find the interest on each of these loans. A, 3,650 loan at 6.5% for 11 months. B, a 2,830 loan at 8.9% for 125 days. C, a 7,900 loan at 7%, loan made on July 7 and due October 25. Okay, so the A is I equals PRT is the formula that we use. For interest equals the principal, which is P, times the rate times time, which is 3,650 times 0.0065 times 11 over 12. This has to be in a year. So 11 months divided by 12 months, that is a year. When you multiply this, you get 217.48 cents. B, I equals PRT again, 2,830 times the interest is 0.089 times 125 days, divide this by 365 days in a year. So 125 divided by 365, that gives you a year. and that is equal to 86.26. $86.26. Then for C, 7,900 at 7%, loan made on July 7 and due on October 25. So here we need to add all the days. So for July, it is in July we have 31 days. 31 days minus 7 is 24 days. August, the whole August, 31 days. September, the whole September, 30 days. October, 25 October. So those, when you add this, you will get 110 days. Then I equals PRT, which is 7,900 times 0.07 times 110 days over 365 days, which gives you equal to $166.66. And here it is. So for A, it is open parenthesis, it is $3,650 times 0.065 times 11/12. And here it is $217.48. That's your interest rate for 11 months. B, just call the previous entry and just change the numbers. It is 2,830 2,830, and it is 0.089 times 125 days divided by 365 days. And that gives you $86.26. That is your interest. Then the C is again called the previous entry. So it is 7,900 times, it is 7%, so it's 0.07, and it is 110 days divided by 365 days, and that is equal to $166.66. Number 2 is simple interest finance for each of the given corporate bonds whose interest rates are provided. Find the semi-annual interest payment and the total interest earned over the life of the bond. A is 12,500 Morgan Stanley 10 years bond, and the interest is 3.75%. B is 10,000 Wells Fargo bond, and it's 10 years bond, and it is at 3.45%. Okay, so A, the semi means you get a bond, you get interest in a bond every 6 months, and that's what semi is. So PRT is equal to 12,500 times 0.0375 times half year, which is 1/6/12, which is half year, and that is equal to $234.38. That's your interest every 6 months. Then for the total, the 10 years bond, the total is PRT equals 12,500 times 0.0375 times 10, which is 4,687.50 cents. So that is the total amount of interest you get in 10 years. B is I equals semi equals PRT, so it's equals 10,000 times 0.0345 times half, and that is 172.50 cents. And this is what it is the interest you get every 6 months. Then the total is I equals PRT equals 10,000 times 0.0345 times 10, which is 3,450. This is the interest you get in 10 years. And here it is. So call the previous entry. So A is it is 12,500, insert, times 0.0375 times half. Okay, it's 12,500 times 0.0375 times half. And this is the semi, this is the interest you get every 6 months, which is $234.38. Then the total interest you get in 10 years is, it is just change the half to 10. So that's equal to 4,687.50 cents. So that's A. B is call the previous entry again and just change the 12,500 to 10,000. 10,000, and the interest rate is 0.0345, and the semi every 6 months, which is 1 divided by 2, every half year you get $172.50, and this is the interest you earn every 6 months. Then the total interest you get in 10 years is second enter again and simply change the half to 10 years. And that is $3,450. That is the interest you earn in 10 years. 3 is feature value of simple interest. Find the feature value and the interest paid of each of these loans The feature value, the formula is A equals P times 1 plus RT. So A is a 3,475 loan at 7.5% for 6 months. So A equals P times 1 plus RT, which is $3,475 times 1 plus 0.075 times 6 months is 6/12. That is a year. Then that's equal to $3,605.31. And the interest earned is the feature value minus the present value, which is $3,605.31 minus 3,475. And that is the interest rate earned is $130.31. Then confirm using TVM solver, financial app TVM solver in TI. So here it is. So the first thing is open parenthesis $3,475 times 1 plus 0.075 times 6 divided by 12. Hit enter, and thus your interest, your feature value, the feature value of 3,475 is $3,605.31. That's in 6 months. Then the TVM solver, go to app, finance, TVM solver. N is, this is simple interest, so N is always 1. Then the interest is 7.5 times, this is 6 months, so this is 6 divided by 12. And that is the interest. The present value is $3,475. PMT, we don't care. The feature value, that is what we are going to calculate, and P over Y is 1. Then the feature value is alpha, solve, and here it is $3,605.31. Number 3B is 6,500 loan at 5.25% for 8 months. So A equals P times 1 plus RT equals 6,500 times 1 plus 0.0525 times 8/12, which is $6,727.50. And the interest is the feature value minus the present value, A minus P, which is $6,727.50 minus 6,500, which is the interest is $227.50. And confirm using TVM solver. And here it is. So open parenthesis 6,500 times 1 plus 0.0525 525 times is 8 months divided by 12 and close the parenthesis, hit enter, and that is $6,727.50. And the TVM solver, go to finance, TVM solver, N is always 1, this is simple interest, so I is 5.25 times, this is for 8 months, so this is 8 divided by 12, and that's your interest. Then the PV is 6,500. PMT, we don't care, it is 0. This is annuity. Thus the feature value, that is what we are trying to calculate, and P over Y is 1. So that's 1. Then just go to the feature value and alpha solve, and here it is 6,727.50 cents. Number 4 is present value of simple interest. Find the present value and the interest earned of each feature amount. The feature amount A is 15,000. It is for 9 months and it is earning 6%. So the present value formula is P equals A over 1 plus RT. So that is 15,000 over 1 plus 0.06 times, it is 9 months, 9 over 12. And that is equal to $14,354.07. This is the present value of this 15,000. And the interest earned is A minus P, which is 15,000 minus 14,354.07, which is $645.93. And confirm your answer using TVM solver. And here it is. So open parenthesis. So it is 15,000 divided by, open parenthesis, 1 plus 0.06 times, it is 9 months, so it's 9 divided by 12, and close parenthesis, hit enter, and that is $14,354.07. To confirm using TVM solver, so just go up, finance, TVM solver, N is always 1, and I is 6%, so that's 6 times, it is a 9 month, so that is 9 divided by 12. And the present value, that's what we are trying to calculate, so that's 0 now. PMT is 0, that's for annuity, and the feature value of this is 15,000, so minus 15,000. And P over Y is 1. Then just go to present value, PV, then do alpha solve. And here it is, 14,000 $14,354.07. Number 4B is the feature value is 15,402 for 120 days, and it is earning 6.3%. So the present value is equal to P equals A over 1 plus RT, which is 15,402 over 1 plus 0.063 times 120 days divided by 365 days, which gives you equal to $15,089.46. And the interest is the feature value A minus the present value P, which is 15,402 minus $15,089.46, which gives you equal to $312.54. And confirm your answer using TVM solver. And here it is, open parenthesis, so it's 15,402 dollars times divide by 1 plus 0.063 times 120 days divided by 365 days. Okay. And equal to, and that is $15,089.46. And the TVM solver, go to App, Finance, TVM solver. So N is always 1, this is simple interest. Then the interest is 6.3% times, this is 120 days divide by 365 days. That's equal to then the PV, the present value, that's what we are trying to calculate, and PMT is the annuity. The feature value is 15,402. Okay. P over Y is 1. Then simply go to present value, alpha solve, and that is $15,089.46. Number 5 is T-bill price and interest rate is finance. Historically, treasury bills offered higher rates. On March 9, 2007, the discount rate were substantially higher than in April 2013. For the following treasury bills bought in 2007, find A, the discount amount, B, the price for the T-bill, and C, the actual interest rate paid by the Treasury. And the T-bill is 3 months 20,000 T-bill with a discount rate of 4.96. The discount is I equals discount is equal to PRT, and the price is the 20,000 minus the discount. So to calculate the discount, it is simply P times R times T, which is 20,000 times the R is 0.0496 times T is 3/12. It is 3 months divided by 12. That makes it a year. And hit enter, and that is $248 is the discount. Then the price is the 20,000 minus the discount, minus 248. And that is the discount. The price is the 20,000 minus the discount, so the price is 19,752. Then the actual interest rate is R equals I over PT. So it is, the actual interest rate is I is $248, that is I is the discount, divide by the price, which is 19,752 dollars times 3/12. That's for 3 months. And that is equal to the actual, the interest, the rate that is paid by the treasury is 5.0223%. He multiplies this by 100, that's the percentage, that is 5.0223%. Number 6 is feature value of simple interest application. This is finance. Michael Bronson invested his summer earning of $3,000 in a saving account for college. The account pays 2.5% interest. How much will this amount to in 9 months? So the feature value is A equals P times 1 plus RT, and the interest is the feature value minus the present value, A minus P. So A, find the total amount in 9 months, which is A equals P times 1 plus RT, which is 3,000 times 1 plus 0.025 times, it is 9 months over 12, which gives you equal to $3,056.25. That is the feature value of this 3,000. That means the interest earned, find the interest earned, I equals A minus P, which is $3,056.25 minus the 3,000, and that is the interest is $56,025. And C is confirm your answer using TBM software. And here it is. So open parenthesis, so it's 3,000 times 1 plus 0.025 times 9 divided by 12. That's 9 months. Okay? Hit enter, and that is the future value of the 3,000 is $3,056.25. That is in 9 months. Okay, and the interest earned is $3,056.25 minus 3,000, which is $56.25. And confirm your answer using TVM solver. So finance TVM solver, n is 1, this is simple interest, n is always 1, then the interest is equal to, it is 2.5% times, this is for 9 months, so 9 divided by 12. Okay. Then the present value of this is 3,000. PMT, that's the annuity, we don't care. The future value, that is what we try to solve, and P over Y is 1. Then come to future value, so that is alpha solve, and that is $3,056.25. Number 7 is present value of simple interest application. It is finance. John Sun-Yi needs $6,000 to pay for remodeling work in his house. A contractor agrees to do the work in 10 months. How much should he deposit at 3.6% to accumulate the 6,000 at that time? So the present value is A over 1 plus RT. So find the amount he deposit today, which is the present value, and the interest earned is I equals A minus B, and confirm your answer using TVM solver. So the amount you deposit today is P equals A over 1 plus RT equals 6,000 over 1 plus 0.036 times, it is 10 months, so it's 10 over 12. That is equal to $5,825.24, and that is the present value of this 6,000 in 10 months. And the interest earned is 6,000 minus $5,825.24, which is equal to $174,076. And confirm your answer using TVM solver. And here it is. So open parenthesis, so it is 6,000 divide by 1 plus 0.036 times 10 over 12. Okay, well, that is $5,825.24. Then confirm your answer using TVM solver. Up finance TVM solver, n is always 1, this is simple interest, and I is, it is 3.6, times, it is 10 months, so it's 10 divided by 12. So that's the interest. Then PV, that is the present value, that is what we're trying to calculate. PMT is 0. The feature value is 6,000 minus 6,000, and the P over Y is 1. It is simply interest. Then go to present value, alpha solve, and that gives you $5,825.24. The next 7 questions are on compounded interest, feature value of compounded interest, present value of compounded interest, and the effective rate or annual percentage yield, APY. The formula for feature value of compounded interest is A equals P times 1 plus I to the power of n. The formula for present value of compounded interest is P equals A over 1 plus I to the n. And the effective rate, the formula is RE equals 1 plus R over M to the power of M minus 1, where M is, if it is yearly, it is 1, if it is semi-annual, which is 2, if it is quarterly, it is 4, if it is monthly, it is 12, if it is daily, it is 365. So number 8, feature value of compounded interest. The following CD were available on www.bankrate.com on April 13, 2013. Find the compounded amount and the interest earned for each of the following. A. Virtual Bank, 10,000 at 0.9% compounded daily for 1 year. So this CD is, the feature value of this CD is A equals P times 1 plus I to the n. P is 10,000 times 1 plus 0.009 over 365 days. It is compounded daily to the power of 365 equals $10,090.41. The interest earned is $10,090.41 minus 10,000, which is $90.41. And confirm your answer using TVM solver. And here it is. Open parenthesis, 10,000 times 1 plus 0.009 divided by 365 to the power of 365. That's equal to, so the amount, the 10,000 compounded daily for 1 year, the feature value of that is $10,090.41. Then the interest earned is $10,090.41 minus 10,000, which is $90.41. And using TVM solver, app, finance, TVM solver. So now this is compounded interest, n is not 1. So N is 1 year, 1 year, and it is compounded daily, so it's 1 year times 365. So that's N. And the interest is 0.9%. Okay, so the present value is 10,000. 10,000 10,000 and PMT, that's annuity, we don't care. The feature value, that is what we are trying to calculate, and it is compounded, it is yearly, it's compounded daily, so that is 365. P over Y is 365. Then go to feature value, do alpha solve, and that is $10,090 and 41 cents. B is Centennial Bank 20,000 CD at 0.45% compounded monthly for 2 years. So the feature value is equal to P times 1 plus I to the N, which is 20,000 times 1 plus 0.0045 over 12, this is monthly, to the power of N. N is 2 times 12, which is 24. And that is equal to $20,180.78. And the interest is A minus P, which is $20,180.78 minus 20,000, which is equal to $1,180.78. And confirm your answer using TVM solver. And here it is. Open parenthesis, 20,000 times 1 plus 0.0045 divided by 12, this is monthly, to the power of N. N is 2 years, 2 times 12 is 24. And hit enter, and that is $20,180.78. Confirm your answer using TVM solver, app, finance, TVM solver, and this is N is 2 years times monthly times 12. So N is 24. Then the interest is 0.45. Then the present value is 20,000. Then the feature value, that is what will be calculated, and it is monthly, so P over Y is 12. Then just do present feature value is alpha solve, and that is 20,180 and 78 cents. Number 9 is interest rate of compounded interest. Find the interest rate with annually compounding of 8,500 that grows to $12,161 in 7 months. So the formula for A equals P times 1 plus I to the n, we are trying to solve for I. So A equals P times 1 plus I to the n. If we divide both sides by P, then 1 plus I to the n equals A over P. Then raise both sides by 1 over n, so it's 1 plus I to the n to the 1 over n is equal to A over B to the 1 over n. This n cancels this n, then 1 plus I is equal to A over B to the 1 over n. Then I is equal to A over P to the 1 over n minus 1. So I equals A over P to the 1 over n minus 1, which is equal to A is 12,161 over P is 8,500 to the power of 1 over 7. N is 7. It is in 7 years. Minus 1, which is equal to 0.0525, which is 5.25%. And confirm your answer using TVM solver. And here it is, open parenthesis, 12,161 divided by 8,500. Okay, to the power of 1 over 7. 1 divided by 7 minus 1. Okay. So it is 12,161 divided by 8,500 to the power of 1 over 7 minus 1. And that's equal to 0.0249, which is, if you multiply this by 100, it gives you 5.25%. Confirm this using TVM solver. So you go to Finance, TVM solver. So N is, it is 7 years. 7 years. It is compounded annually, so it's compounded annually means 1 times 1, once a year, so that is N. Then the interest is, that is what we're trying to calculate, so just leave it 0. The present value is 8,500. 8,500, and the feature value is 12,161. 12,161, and it is compounded yearly, it is annually, so P over Y is 1. Then simply go to the interest, then do alpha solve, and it gives you 5.25%. 5.25%. Number 10 is present value of compounded interest. Finance. Find the present value and the interest earned of each of the future amount and decide A. If money can be invested at 7% compounded quarterly, which is larger, 2,000 now or $2,420 in 5 years. So now we are comparing the 20,000 to the 2,000 to the 2,420 in 5 years. So we need to bring the 2,420 to present value, then compare the money now to now. We need to bring to know the present value, which is the now value of this 2,420. So the future value is 2,420, and P equals A over 1 plus I to the n. That is 2,420 over 1 plus 0.07 over 4, this is quarterly, to the power of, it is in 5 years, so it is 5 times 4, which is 20. Then this is equal to 1,710.52. The interest earned is 2,420 minus 1,710.52, which is 709.48. So now the comparison is, if I'm going to give you 2,000 now, or if I give you a choice between 2,000 now or 2,420 in 5 years, the present value of this 2,420 is 1,710. So it is now, the comparison is 2,000 now is greater than 1,710.52 cents now. So these two are now. That means this is greater than this. That means the 2,000 now is greater than the 2,420 in 5 years. Here it is, $2,420 divided by 1 plus 0.07 divided by 4 to the power of 20. Equal to, and that is $1,710.52. And that is compared to the 2,000 now. 2,000 now is greater than this 1,710.52. That means the 2,000 now is greater than the 2,420 in 5 years. And confirm this using TVM solver, app, finance, TVM solver. Then this is the n is equal to, it is 5 years times, it is quarterly times 4, so n is 20, and the interest is 7%, and the present value, that is what we're trying to get, so that is 0. Then the future value is minus 2420. And P over Y is, it is quarterly, it is 4. Then go to present value alpha, solve, and that is $1,710.52, and that is the 2000 is greater than this. That means the 2000 now is greater than the 2420 in 5 years. Number 10b is if money can be invested at 8% compounded annually, which is larger, 18,000 now or 30,000 in 6 years. So we need to get the present value of this 30,000, and that is P equals A over 1 plus I to the n, which is 30,000 over 1 plus 0.08, that's the percentage, divide by 1, it is compounded annually, to the power of n is 6 years times 1, which is 6. Then this is equal to 18,905.09 cents. So that means the interest earned is A minus P, which is 30,000 minus 18,905.9 cents, which is $11,094.91. So now the comparison is, if I have 18,000 to give you now, or 30,000 to give you in 6 years, which one is greater? So this 30,000, its present value is $18,905.09, which is greater than 18,000. That means this 18,905 is greater now, is greater than 18,000 now. That means that 30,000 in 6 years is greater than 18,000 now. And confirm your answer using TVM solver. And here it is. Open parenthesis. 30,000 times divide by 1 plus 0.08 divide to 1, it is yearly, to the power of 6. Okay, hit enter, and that is $18,905.09, and that is obviously greater than 18,000. That means the 30,000 in 6 years is greater than 18,000 now. And here is the TVM solver, finance, and the n is 6 years times annually, it's times 1. So that's your n, and the percentage is 8%, and the present value is, that is what we try to calculate, and the feature value is 30,000, and is compounded annually, so it is 1, P over Y is 1. Then go to present value, just do alpha solve, and that is $18,905.09. Okay, which is obviously this is greater than the 18,000 now. That means the 30,000 in 6 years is greater than 18,000 now. Number 11 is face value and present value of zero coupon bond. Solve the following zero coupon bond problems. A. Find the face value and interest earned to the nearest dollar of the zero coupon bond. 10 years bond at 4.1%. Price is 13,320. So the feature value is the face value is always, face value means always feature value. The feature value is A equals P times 1 plus I to the N, and the interest earned is A minus P. So A equals P times 1 plus I to the N, which is 13,328 times 1 plus 0.041 divided by 2, because the bond always earn interest every 6 months, which is every half year. So that's semi-annually. To the power of n, it is 10 years, and it earns twice a year, so that is 20. That is 10 times 2, 20. That gives you 19,999.78 cents. And the interest earned is A minus P, which is 19,999.78 minus 13,328, which is $6,671.78. And confirm your answer using TVM solver. And here it is. $13,328 times 1 plus 0.041 divided by 2, close it, to the power of 20. That's equal to 19,999.78 cents. Okay, and confirm using TVM solver, Apt Finance TVM solver, and that is N is, it is 10 years, and it is semi-annual times 2, and the interest is 4.1%, so 4.1, and the present value is 13,300 $13,328, and the feature value is that's what we'll calculate, and it is semi-annual. It is a bond, it's semi-annual, which is 2. P over Y is 2. Then the feature value is alpha solve. Then here it is 19,999.78 cents. Number 11B is find the present value, the price you will be willing to pay, and the interest earned for the zero coupon bond, 15 years, a 20,000 bond, interest at 4.7%. So the present value is equal to P equals A over 1 plus I to the N, and the interest is a minus p. I equals a minus p. So the p equals a over 1 plus I to the n, which is 20,000 over 1 plus 0.047 over 2. This is bond, so it is semi-annual, to the power of n is 15 years times 2, which is 30. Then this is equal to $9,963.10. That's the present value of the 20,000 in 15 years. Then I is equal to A minus B, which is 20,000 minus 9,963.10, which is $10,036.90. And confirm your answer using Finance app TVM solver. So here it is. So open parenthesis, 20,000 divide by 1 plus 0.047 divide by 2, it is semi, it is a bond, it is semi, to the power of 15 years times 2 is 30. And that's equal to $9,963.10. And the interest is 20,000 minus this $9,963.10, and that is $10,036.90. And here is the TVM solver app, Finance TVM solver. N is, it is 15 years, and it is semi-annual, it is a bond, so it is times 2, which is 30, and it's 30, and the I is 4.7%, and the present value, that is what we try to calculate, 0, and the future value is 20,000. And it is semi-annual too. Then go to present value, do alpha solve, and that gives you $9,963.10. Number 12 is effective rate or annual percentage yield, APY. Find the APY RE, which is corresponding to, which is effective rate corresponding to the given nominal rate. So the effective rate formula is RE equals 1 plus R over M to the power of M minus 1, where M is, if it is yearly, it is 1, if it is semi-annually, it is 2, if it is quarterly, it is 4, if it is monthly, it is 12, if it is daily, it is 365. So A is the annual rate, is the nominal, A is the nominal rate, is R equals 6% compounded quarterly. So that means RE equals 1 plus R over M to the M minus 1, which is equal to 1 plus 0.06 divided by 4 is quarterly to the power of 4 minus 1. which gives you equal to 0.06136, which is 6.136%. B is the nominal rate is 4% compounded semi-annually. That means the effective rate RE is equal to 1 plus R over M to the M minus 1, which is 1 plus 0.04 over 2 to the power of 2 minus 1, which is 0.0404, which is equal to 4.04%. And here it is. A is 1 plus 0.06 divided by 4 to the power of 4 minus 1. Okay, so it is 1 plus 0.06 over 4 to the power of 4 minus 1, and that is equal to 0.061136. If you multiply this by 100, and that is a percentage, which is 6.136%. B is called the previous entry, and that is 1 plus 0.04 divided by 2. It is semi-annually, compounded semi-annually, divided by 2 to the power of 2 minus 1, and that's equal to 0.0404. If you multiply this by 100, it gives you 4.04%. Number 13 is future value of compounded interest application. It is finance. A developer needs 80,000 to buy land. He is able to borrow the money at 10% per year compounded quarterly. How much will the interest amount to if he pays off the loan in 5 years? A. Find the total amount that will be paid. B. Find the interest that will be paid. Then C is confirm your answer using TVM solver. So the total amount is the future value equals P times 1 plus I to the n, which is 80,000 times 1 plus 10% is 0.1 divided by 4, it is quarterly, to the power of, it is 5 years, 5 times 4, which is 20. Then this is equal to $131,089.32. The interest is I equals A minus P, which is $131,089.32 minus the 80,000, which is the interest is going to be $51,089.32. Then confirm your answer using TVM solver. So here it is. So it is 80,000 times 1 plus 0.1 divide by 4 to the power of 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . 20 . hit enter, and here it is $131,089.32, and the interest earned is that minus the 80,000, which is $51,089.32. And to confirm this using TVM solver, app finance TVM solver. So N is here, it is it is 5 years times 4, it is quarterly, so times 4, compounded quarterly. Then I is 10%, and the present value is 80,000. PMT, we don't care. The feature value is, that's what we are trying to calculate, and it is quarterly, so this is 4. P over Y is 4. Then the feature value, just do alpha solve, and here it is $131,089.32. Number 14 is present value of compounded interest is finance. It is an application. Bill Boley wants to have 20,000 available in 5 years for a down payment on a house. He has inherited 16,000. How much of the inherited should be invested now to accumulate 20,000 if he can get an interest rate of 5.5% compounded quarterly? So we're going to find the present value. A, find the total that must be invested now, which is the present value. P equals A over 1 plus I to the n, and the interest that will be earned is I equals A minus P. Then confirm your answer using TVM solver, and here it is. So it is 20,000 over 1 plus 0.055 divided by 4. It is quarterly to the power of 5 times 4, which is 20. That is 5 years. And that gives you 15,220. Okay? And that the interest is 20,000 minus 15,220, which is 4,780 and 7 cents. And confirm your answer using TVM solver. And here it is. Open parenthesis. So this is 20,000 times the divide to the 1 plus 0.055 divided by 4 to the power of 20. And that is equal to $15,219.92, which is 15,220. Okay, and the interest is 20,000 minus 15,220, which is 4,780 and 7 cents. And confirm your answer using TVM solver. So go up, finance, TVM solver, and that is N is 5 years and it is quarterly times 4. So that's 20. Then the interest is 5.5%, and the present value, that is what we are trying to calculate, and the future value is 20,000. And the P over Y is 4, it is quarterly. Then go to present value, alpha solve, and here it is $15,219.92, which is about 15,220. The next 4 questions are on future value of ordinary annuity, payment of future value of ordinary annuity, and future value of annuity due. So number 15 is future value of an ordinary annuity application. It is finance. A typical pack-a-day smoker in Ohio spends about $170 per month on cigarettes. Suppose the smoker invests that amount at the end of each month in an investment fund that pays a return of 5.3% compounded monthly. What will the account be worth after 40 years? Okay, so A, the account worth after 40 years, use the formula. The annuity, the future value of annuity is S equals R times 1 plus I to the n minus 1 over I, which is $170 times 1 plus 0.053 divided by 12, it is monthly, to the power of, it is 40 years, 40 times 12 is 480, minus 1 over 0.053 over 12, and that is equal to $280,686.25. And confirm your answer using TVM solver. And that is this smoker quitting the smoke and investing that money for 40 years into this annuity will give him $280,686.25 in 4 years, which this is big money. And on top of that, more than that, he will have his health, because for 4 years he will not be smoking, instead he will be investing, and this investment he will give him his health, good quality of life, plus this money. And here it is, open parenthesis, it is $170 times, open parenthesis, 1 plus 0.053 divided by 12 to the power of 480 minus 1, and close that, divide by open parenthesis 0.053 divide by 12, close that, equals $280,686.25. Confirm this using TVM solver app, finance, TVM solver, and the N is here, it is 40 years, it is monthly times 12, and that's 480, and the interest is 5.3%, 5.3, and the present value, we don't care about that, we are looking for future value, and the payment is making $170 payment every month, and the future value, that is what we're trying to calculate, and it's monthly, so it is 12. P over Y is 12. Then go alpha solve, and that is the amount he will be having in 40 years. He will have 280,686.25 plus a good health and good quality of life. Number 16 is future value of an ordinary annuity payment applications. Finance. Barbara Margolios wants to buy a 24,000 car in 6 years. How much money must she deposit at the end of each quarter in an account paying 5% compounded quarterly, so that she will have enough to pay for her car? And this is calculated the payment R, which is PMT in the TVM solver. So S equals R times 1 plus I to the N minus 1 over I. Then R is simply cross multiplication SI over 1 plus I to the N minus 1. So each deposit must be then calculate R. So R is SI over 1 plus I to the N minus 1, which is 24,000 times 0.05, that's 5% over 4, it is quarterly, divide by 1 plus I is 0.05 divided by 4 to the power of N. N is 5 years times 4, 6 years times 4, which is 24 minus 1. And that is gives you $863.68. That is the monthly payment. And this monthly payment will be accumulated to be 24,000 in 6 years. And use TVM solver to verify. And here it is. So it is 24,000 times 0.05 divide by 4 divide by 4, divide by, open parenthesis, open another parenthesis, 1 plus 0.05 divide by 4 to the power of 24 minus 1 close bracket. That's equal to $863.68. And using the TVM solver, P finance TVM solver, so this is N is equal to, it is 6 years, and it is quarterly times 4, and the interest is 5%, present value we don't care, the payment is, that is what we trying to calculate, and the future value is 24,000. And the P over Y is, it is quarterly, so it is 4. Then go to future value, no, the future, the payment. So it is alpha solve, and that's, here it is $863.68. That is the monthly payment. Number 17 is future value of annuity due. So this time it is annuity due, which is the payment are made at the beginning of the month. It is finance. A grandmother opens an investment for her only granddaughter on the day she was born, investing $500 each year on her birthday. She deposited another $500, making the last deposit on her 25th birthday. If the account paid is a return rate of 6.2% compounded annually, how much is in the account at the end of the day on the granddaughter's 25th birthday? So the annuity due formula is S equals R times 1 plus I to the N plus 1 minus 1 over I minus R. So account at the granddaughter's 25th birthday is 29,966.97 plus, remember she made 500, she deposited another 500, making the last deposit, but that 500 doesn't earn any interest, so it is just plus 500, and that makes it 30,466.97, and thus final in the account. That is her, the grandmother presented to her granddaughter. So S equals R times 1 plus I to the N plus 1 minus 1 over I minus R, which is 500 times 1 plus 0.062, it is annual over 1, to the power of 25 plus 1 is 26 minus 1 over 0.062. Annual, it is over 1, minus the 500, that makes it equal to 29,966.97. Then add the 500 that was made at the end of on the 25th birthday, and that makes it 30,466.97. And confirm your answer using TVM solver. And here it is, open parenthesis, it is 500 times 1, open parenthesis, open another parenthesis, 1 plus 0.062 open close parenthesis to the power of 26 minus 1 and close parenthesis, and divide that by 0.062 and close parenthesis, subtract minus 500. That's equal to and that's equal to 29,966.97 cents plus the 500 deposit at the end, and that gives us 30,466.97. Confirm your answer using TVM solver, finance, TVM solver, and the n here is 25 times 1. It is annually. The deposit was made every year, so it is just 1. Then the interest is 6.2%, and the payment is $500. Then the feature value of this is, we are trying to calculate that, and it is annually, so P over Y is 1. Then do alpha solve, and that is 28,000. This is annuity due, so we need to change end to begin. Then go to alpha solve, and that is 29,966.96, and that is, make sure that it is annuity due, so you need, it is, the payment is done at the beginning of the month, so that you need to change that to begin. Number 18 is feature value and annuity due payment application. It is finance. Find monthly payment for 12 years that should be used for the annuity due, whose feature value is 55,000 and the interest rate is 5.7% compounded monthly. So the formula for annuity due is S equals R times 1 plus I to the power of n plus 1 minus 1 over I minus R. So to calculate the payment, if you factor out R, S equals R times 1 plus I to the n plus 1 minus 1 over I, then R is S divided by this, which is S divided by 1 plus I to the n plus 1 minus 1 over I minus 1. So R equals S over I 1 plus I to the n plus 1 minus 1 over I minus 1. So this is 55,000 over 1 plus I is 0.057 over 12 to the power of 145. N is 144. It is 12 times 12 plus 1, 145 minus 1 over 0.057 over 12 minus 1, which gives you equal to $265.71. And here it is. Open parenthesis. So it is 55,000 open parenthesis divide by open parenthesis 3 times, then it is 1 plus I 1 plus 0.057 divide by 12 to the power of 145 minus 1, close that and divide that by 0.04057 divide by 12, close it, minus 1, and close it, and that is equal to $265.71. Now use the TVM solver to confirm. So it's finance TVM solver, and N is here, it is 12 times 12. So it is 12 times 12, it is not 144 plus 1. This is a TVM solver. The TVM solver will take care of that one when you change this to begin. So then the interest rate is 5.7%, 7%, and the present value, we don't care about that. The payment is, this is what we'll calculate, and the future value of the amount is, it is 55,000. and the P over Y is monthly, so it is 12. So calculate the payment, which is alpha solve, and that is $265.71. And here is the TVM solver confirmation. It is $265.70. Now the last two questions are on present value of our ordinary annuity and amortization payment of an ordinary annuity and the present value of annuity due. So 19 is present value of our ordinary annuity application. It is finance. The stereo dealer sells a stereo system for $500 down and monthly payment of $35 for the next 3 years. If the interest rate is 1.35% per month on the unpaid balance, find A, the cost of the stereo system, B, confirm your answer using TVM solver. So the cost of the stereo is P, which is the payments, the $35 payments for 3 years. That is P equals R times 1 minus 1 plus I to the power of minus N over I. This is the present value formula for annuity. So that is 35 times 1 minus 1 plus 0.0135. Notice it says per month, so that means this is monthly, so you do not have to divide by to the power of this. N is, it is 3 years, 3 times 12 over I is 0.0135. This is monthly, so you do not have to divide by 12. So this is equal to $992.74. That is the payment plus the $500 down payment, and that makes it $1,492.74. And confirm your answer using TVM solver. And here it is. Open parenthesis, $35 times 1 minus, open parenthesis, another parenthesis, 1 minus open parenthesis 1 plus 0.0135 to the power of minus 36 close this, close it again, divide by 0.0135 and close it and hit enter. $35 times 1 minus 1.0135 to the power of minus 36 divide divide 2.0315, and that is $992.74. And using the TVM solver app, finance TVM solver, N is here, it is 3 years times 12. It is monthly, so it is times 12. So that is N. That is 36. And the interest is 1.35 per month. So it's just 1.35. It is per month, and the present value is, we don't care. No, that's what we are trying to calculate. And the payment is $35. And the future value, we don't care, this is present value, and it is 12. P over y is 12. No, P over y is 1 because it is the I is given just in a month, per month. Okay. So then go to present value, then do alpha solve, and that is, we need to change this is ordinary annuity, so it is end. Then if you go to future value, alpha solve, and that is $992.74. The last question is number 20, ordinary annuity payment application is finance. John Smith will purchase a 300,000 home with a 25 years mortgage. If he makes a down payment of 25% and the interest rate is 2.9% compounded monthly, A, what will the monthly payment be? B, confirm your answer using TVM solver. So for the ordinary annuity, present value formula is P equals R times 1 minus 1 plus I to the minus N over I. Then to calculate R is equal to Pi, let's do cross multiplication, Pi over 1 minus 1 plus I to the minus N. So this is equal to, P is, he made 25% payment, down payment, so that means what is left is 300,000 times 1 minus 0.25. 1 means 100% minus 25%. Times I is 0.029 over 12. This is monthly. Divide by 1 minus 1 plus 0.029 over 12 to the power of minus 300. N is it is 25 years times 12, which is 300. Then confirm your answer using TVM solver. And here it is. So open parenthesis, 300,000, 300,000 times 1 minus 0.25 times 0.029 divided by 12. Divide, open parenthesis, 1 minus, open parenthesis, 1 plus 0.029 divided by 12, close parenthesis, to the power of minus 300. And hit enter, and that is the payment is $1,055.31. Then TVM solver, go to finance, TVM solver. This N is, it is 25 years. It is monthly times 12. And that is 300 N. And I is 2.9%, 9%, and P, the present value is $300,000, 300,000, 300,000 times 1 minus 0.25. And that is 225,000. And the payment is, so it's 0 here, this is a so we are to calculate PM, and it is monthly, so it is 12, and it is ordinary annuity, so the payment is alpha solve, and that is $1,055.31. And that is the end of exam 2 review, and thank you. Please subscribe, share and like, and ask your friends to subscribe, share and like.